So, welcome, Clay. Thank you for being here. Clay is a mechanical engineer at Maxar Systems Engineering. Um, he says he does payload and propulsion, and he will hopefully tell us what that's about. And he also was at Blue Origin, or are you at Blue Origin now? And you were at Maxar.
Uh,
I'll let you
yeah,
clarify that,
correct. So
Clay,
that's
but welcome. Thank you so much for being here.
yeah, of course. Happy to be here. This is probably a cheesy question. At least can everyone hear me all right?
Yes.
Okay, great. Yeah. So my name's Clayton Jerstad. No worries on the pronunciation. Most people don't get it right the first time. So yeah, for myself, I used to work for Maxar Technologies as a propulsion engineer as well as a configuration engineer for payloads. And I also was a systems engineer for a short stint there as well. And about a year ago, I moved over to Blue Origin to help develop their umbilicals program. So I guess kind of going just a little bit of background about myself. I am local to the Santa Cruz area. I grew up going in Scotts Valley. So went to Brooknell Elementary School, Scotts Valley Middle School, then graduated Scotts Valley High School in 2009. I would say my career path has been a little unorthodox. Right out after graduating high school, um, pretty much knew I wanted to do engineering, but really didn't have the motivation to do well in school. So I actually signed up for Engineering 5, the same class you guys are in, but I did not do any of my assignments and actually failed with Joanne my first attempt through.
Oh no.
So uh, after that, I kind of decided that it wasn't really my time to go to school and really pursue that. So after that, I moved up to South Lake Tahoe, where I managed a ski shop during the winters, and then I would manage a boat rental company during the summers, or on some summers, I would actually go down and ski in Argentina and Chile and kind of chase that endless winter. After about 5 years of doing that, and a few different injuries here and there, I kind of decided that wasn't what I wanted to do with my life. And at this point, I was really ready to go back to school. So I left Lake Tahoe. I moved back in with my dad in Scotts Valley, started classes at Cabrillo, where I spent 2 years doing my math and undergrad. And then I transferred to San Jose State in 2017, where I spent 2 years there as well. And then graduated in 2019. I was very fortunate and got a job offer about halfway through my senior year with Maxar. And then after working with them for about 3 to 5 years, I left and switched over to Blue Origin, where I now reside in Washington. And I'm currently working on my master's in mechanical engineering at the University of Washington. I had some questions here. Yeah, that's
Um,
pretty much all that. Yeah, and so I know I had some questions here. So, like, how did I decide on engineering and my particular major? Um, from a really young age, I really enjoyed taking stuff apart and sometimes was able to put it back together. Sometimes I wasn't. But I've always just really liked solving problems. So I think that's what really drew me into engineering is just solving problems. And I really believe that's what engineering is all about. Um, and so for my particular one, I was an avid skier and mountain biker. And so I was 90% sure I was going to end up in either the ski industry or mountain biking. So mechanical just made the most sense to me. And then as I kind of learned in my educational career, and I'm sure you guys will learn as well, engineering is an immensely diverse field. There are so many different things that you can do. And a lot of the times your skill set will be very relevant in fields that you'd never had imagined before. Like I never would have guessed I would have ended up in aerospace, but I really enjoy it and really glad I kind of did.
and what kind of work do you do in the aerospace industry? What would you say?
Um,
I know you said umbilical systems, but what does
yeah.
that mean?
Okay, so I do have a cool little video for you guys because most
Oh,
people don't. So hold on real quick. We'll get this queued up. Oh, come on, commercials. All right, how do I share my screen on this guy? Zoom, share screen.
And
that's
you
the
may
one I
need to
want.
also share sound if it's a video.
Okay. Oops. So I don't think this sounds as important. So for those of you who aren't familiar, New Glenn is a rocket company. We have successfully launched New Shepard multiple times now, as well as having crews on it. So I work on New Glenn, so this isn't specific to me, but it's a good idea. So if you can see my mouse, does it still have the same screen?
Yes.
Okay, cool. So this little guy right here coming out is going to be your umbilical. So essentially, it's the same thing as when you're having a baby. The umbilical is going to provide all the fuel, oxygen, and everything the rocket needs to essentially take off. So I work on GS2, which is the second stage of New Glenn, where we use liquid hydrogen and liquid oxygen as our propellant systems. So if we kind of play this a little bit, we get a much better view of the umbilical. So essentially, I'm not sure how familiar you guys are with chemistry, but liquid oxygen and liquid hydrogen are very cold. So here's a really good shot of the umbilical. So on these ones, you'll have your commodities flowing through, as well as some of these avionics cables. And my responsibility and role right now is really this interface. So it's a lot more complicated than I think it seems, but essentially like an umbilical is the same thing as like when you're filling your car up with gas. So you have one side that's going to stay with the vehicle and one side that's going to stay at the gas station. Except with ours, we're flowing things at like negative 200 degrees. And so it gets very, very cold and materials act very differently. So we have to make sure that essentially everything's compatible, as well as making sure all our safeties are in effect. So hydrogen and oxygen are very flammable, especially when they're in liquid form. So everything is very, very scrutinized. And also, it's very, very important that we're able to release on time. So if you ever work in cryogenics, the number one rule of cryogenics is not to have breaks in the line or valves or anything like that, because you're going to always have leakage. And so we pretty much get to break every single one of those and come up with very clever solutions to do with what leaks, because there's just really no way to get around it. So if we kind of play through here, so you'll see right there, it pops off pretty much right when the rocket goes, which is critical for timing. And then it launches. So that's my current role, is working and developing those systems. We actually have a recovery one too for New Glenn, because that one is reusable and lands on a barge. Before
So did that
this,
umbilical go with the rocket?
no,
Or
it detaches
separated?
right before it. So I won't
It-
pause it this time so we can see it. So right
Oh,
there, it's gonna go. The rocket
the
starts
rocket is
moving.
what's behind.
Yep.
I see. Oh, I see. I see. I didn't realize we were looking at it from that view. Okay.
Oh yeah,
Yeah.
no worries. Yeah, so that's the interface that I work on right now, except for New Glenn instead of New Shepard, which is much, much bigger. Yeah, so that's kind of my work right now. I really enjoy it a lot, because as it's still a lot of new technology for us, I get to design a lot of the components. And pretty much once I'm finished, the first question I ask is, how am I going to test it, qualify it, and get it ready for production? Which is something that I didn't really have in my previous role.
And did you get to travel to the site to see all that
Mhm.
happen? So because that was in Florida, right? Or Texas?
That's actually out of Texas.
Texas. Okay.
I haven't been to Texas yet, but I've been to Florida a few times. So Blue Origin currently occupies Launch Site 36, which is not that far from where SpaceX is.
Mm-hmm.
So we have the pad. I'm not sure if you guys follow a lot of space stuff, but we just did a dry fill and fueling on the pad with New Glenn. So that was pretty cool for us here.
Very cool.
Um,
There's a question in the chat, and it's a little further up. What was your experience like as a re-entry student at Cabrillo versus a four-year institution? Do you think it impacted employment opportunities positively, negatively? Not at all.
So employment, no. I will say, kind of going to San Jose State at being a little bit older, sometimes you felt like you stuck out, but to be honest, there was I think a few 60-year-olds in my class who were going back.
Oh,
So for me, I would say not at all. And most of uh, so when I transferred to San Jose State, I did it with 3 or 4 of my friends that I met at Cabrillo. Some of us were younger and some of us were older, but essentially we kind of stuck through it together. So yeah, just the age was never really an issue for me at all. And I don't really see it in the industry much either. I know people who are like 60 years old and their manager's 30. Um, yeah, age, at least in the companies I've worked and the universities I've gone to, have been not an issue at all.
that's really nice to hear. There's another question. Did you ever believe you'd be working on rockets when you didn't pass engineering five the first time?
No, so no, and like I said, it just wasn't my right time to be in school, and I had other priorities in life, mainly riding my bike and skiing. And so, yeah, never in a million years I think I was going to be in the aerospace industry. And that's actually kind of an interesting story how I actually got my first job at Maxar, which I went straight into the aerospace industry. I was actually recruited by a friend who had graduated a few years before me, and he asked me for my resume, and I wasn't sure what it was for, and I actually submitted it to his manager on my behalf. And then I got a call and then follow-up interviews. And like I said, I ended up getting a job offer in December of my senior year, which took a lot of pressure off me, not having to job hunt anymore and just having that so I could really focus on finals and my senior design project.
Was that a former student at San Jose State who did that? Called you up?
Yes.
Oh,
Mhm.
okay. That's
Yeah.
great.
So I huge plug for San Jose State. If any of you guys are planning on going there, it is a wonderful school with a lot of opportunity. It may not have the most prestigious name, I would say sometimes, but the job opportunities that you have to network in the industry and while you're even a student to really get hands on, we partner with a lot of people in Silicon Valley, and you
Mhm.
can pretty much find any single industry. So Maxar Technologies, their headquarters is in Colorado, but they still do their satellite manufacturing in Palo Alto. So there's a lot of industry right there.
Cool. You mentioned a senior project. Can you tell us a
Mhm.
little bit about that?
Yeah, so pretty much at San Jose State, for your senior year, everyone's required to do a senior project. Essentially, all the professors line up with their ideas and what projects that you can work on for the year. And then they say go, and everybody runs to the professors to try and sign up first.
Hmm.
Um, so the one that we chose, we really wanted to have a final product. So some of them are very ongoing, like there is an autonomous program with a golf cart, but that's been going on for 7, 8 years right now, and still kind of just tinkering with it. So we wanted something that we could deliver in the end. So the VTA, the Valley Transportation Authority, or the bus system up in Santa Clara, uh, they have to wash an insane amount of bus rims. And so they didn't want to have to buy any machines and kind of contracted us out to build them one that would meet their specifications and what they needed that would integrate into their facility. So we worked with the Valley Transportation Authority. We built essentially a bus rim cleaning device. So when the rims are off the bus, they can just strip the tire off, toss it in this machine. In 30 seconds, it's done. And then they can mount a new tire onto it. So that was a lot of fun. And like I said, it sounds very simple, but as I'm sure you guys will all, if you don't already, even the little things, it's an incredible amount of detail and work to make sure everything fits together. So we finished in the end and actually were able to hand off a product and turn it on and it all worked. So it was really satisfying to have that.
Wow, congratulations. That's amazing. What a great experience.
Mm-hmm.
Um, do you want to talk about some of your favorite projects that you've worked on at Maxar, maybe you've already talked about the umbilical cord and that is your favorite project.
Yeah. So that one's really fun, but I do think my time at Maxar, even though I would say I was more of a at Maxar, some of the projects I got to work on were very cool. So one of the first programs I worked on was called Psyche. It was in partnership with JPL down in down south. Um, and essentially, what the program was is a doctor in Arizona State had theorized that one of these asteroids in the asteroid belt, named Psyche, was developed in a similar way that Earth was way back in the day. And so for this one, though, essentially all of its crust had gotten blown away by meteors and stuff like that. And so essentially this asteroid was supposed to be very, very representative of our core, the core of the Earth. And
Mhm.
so Maxar was contracted out through JPL and Arizona State University, I think it was Arizona State, to essentially build a satellite to go out to this asteroid with magnetometers, spectrometers, cameras, as well as a variety of other instrumentation in order to better understand Earth's core by examining this asteroid. Um, so that I was the systems engineer on, so I worked very, very closely with JPL. Um, in case anyone is wondering what a systems engineer does or is, it was my job to ensure that the product we built is what the customer wants. And yeah, just making sure everything kind of lines up.
Wow, that sounds really cool. Did you see that project to completion? Did your satellite land on it?
Unfortunately, again, anyone follows space news, there were some software issues that caused us to miss our launch window. So I haven't really followed it since we missed that one. I believe it was supposed to be back in 2022, and I think the next window to get out there was like 2026 or something like that. So
Yeah.
space travel is very, very difficult, and you kind of have to wait for everything to line up. And so it's very, very important, um, as I just mentioned, to meet your deadlines. We have a famous saying, or I shouldn't say we, but one of my manager's favorite sayings is Christmas doesn't move. So you have to be ready with your product on time. And if you miss the launch window, you could be waiting years to have it again. So it's very, very important to meet your deadlines.
Yeah. Um, how do you keep sensitive equipment protected during launches? Doesn't the high G affect all the tiny little pieces?
Oh, it does. So essentially, that's a problem that most of the aerospace industry faces. Um, Again, a good saying is you design a satellite for about 2.5 minutes, meaning everything in there is way overkill and it's designed to withstand those G forces. And once it gets to space, 90% of the spacecraft is useless, which is very good when you're thinking it's hundreds of thousands of dollars per kilogram that you have to launch into space. And so there are a lot of companies looking for and looking into on orbit manufacturing or in orbit manufacturing. So instead of building these very strong structures to withstand all those G forces, you could essentially build it in space with a lot less. But yeah, you pretty much design everything for about 2.5 minutes. And really, the only thing that you need once you're up there is the payload, and that's pretty much it. But the payload's also overkill because it needs to withstand those forces as well. So yeah, you design a satellite for 2.5 minutes, and yeah, it's a lot of extra weight.
I think we probably have to wrap things up here. I know that we haven't
Okay.
got some of our other questions that I had sent you. What is this? I guess the engineering degree impact on your life or quality of life, if you want to address that, and a suggestion you have for these students as they are embarking on this path that you completed not too long ago.
Yeah. So quality of life. I mean, I really enjoy my job. Honestly, no matter where you kind of go or what you choose, I think that's going to be the most important thing. You know, you could not be making a lot of money, but be the happiest person in the world. I mean, engineering does pay well, so that's a big benefit, but don't get me wrong, it's very hard work. But if you enjoy that, you really enjoy problem solving, and you enjoy not knowing all the answers, then I think it's very, very fulfilling and satisfying.
Mhm.
And as far as a piece of advice, honestly, just stay humble. I mean, you really want to be a continuous learner, and I think that's what's allowed me to really excel in my career is just anytime opportunities come up for me to work on something new or something I'm unfamiliar with, I try to jump at it every time, and I think it's been very, very beneficial for me. I've gotten to work on secret programs that no one knows about, um, as well as other ones that are very public, like Psyche. Um, so yeah, just stay humble, ask a lot of questions, really be that lifelong learner, um, and never judge a book by its cover. Machinists will tell me I have done something really dumb, and most of the time they're right. But you can always learn more. So just everyone's an expert somewhere. And if you can figure out what they're an expert in, you can always learn from them, no matter what their job is or what they're doing. So just stay humble and ask a lot of questions.
Great advice. Did you say you were up there getting a master's right now too?
Yep.
Yeah,
Yeah.
and is
I'm
that in
working,
aerospace or is it in mechanical?
I'm doing mechanical engineering.
Okay. Okay. Great. Um, and Clay, do you know Melissa Pardo? She has spoken to our class before and she's at Blue Origin.
Yeah. She's actually my wife.
Oh, okay.
So
Well,
that's another fun fact. I met my wife at Cabrillo. So her and I have
yeah.
gone through this for a bit.
Oh, wow. I had no idea. Okay, cool. Yes, so we actually have several couples that have come out of Cabrillo, and I didn't realize the connection. Okay, awesome.
Yep.
Well, thank you so much for being here and sharing all of this cool stuff with us. It was really nice to meet you and to learn about the work that you're doing.
Yeah, I'm happy to do it. And if anyone has any questions or follow ups, or even if they're interested in internship opportunities, definitely feel free. You're more than welcome to share my email with the class.
Okay.
Yeah, anyone's feel free to email me, or if you see internship opportunities, I'm happy to recommend you or talk to you about it. And yeah, I mean, it's going to be tough. It only gets harder, but it's really worth it. Once you kind of get through, I think it's very rewarding. It's that old saying, nothing good comes easy. So just it'll be hard and you'll have your low days, but it'll always be better.
Awesome. Thank you so much. And I will share yours and Steve's email addresses with the
Mm-hmm.
class. All right. There's a bunch of thank yous in the chat for you.
Oh yeah, of course. Yeah. Thank you guys. It's a pleasure to speak with you. And yeah, really excited to see what Cabrillo's engineering program has become. It seems like it gets bigger and bigger every year. So it's really amazing.